Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to time response analysis. So here uh, we are with another question, and it is given that a system with unit feedback is represented by the differential equation d square c dt square plus 8 dc by dt, which is equal to 64e, where here E is R minus C, R is the input, C is the output. Okay, so here it is the question is given in a different way as compared to what we have dealt with previously. So if you remember, uh, the the control system, the general format of a control system, it is basically in this way. Okay, like this. Okay, like this. Here RS, CS, these are all in frequency domain, where S is equal to j omega, and it is converted from time domain to this S domain with the help of a mathematical technique called as Laplace transform. There are other techniques also, such as Fourier transform, Z transform, which we have discussed in signals and systems. So basically what we'll do here is that we'll be converting this time domain C, which is here, it is basically in this format, CT, RT, ET, we will convert it into CS, RS and ES with the help of Laplace transform. Okay, so here this is the error signal that we get here. This is the error signal. Okay, this is positive, this is negative, that's why it's called as negative feedback system. So here this is in time domain here, as it is given here, ET is equal to RT minus CT, which will get here this. So for that we'll be taking Laplace transform of both sides. So first we'll write the equation which is given, d square c by dt square plus 8 dc by dt, which is equal to 64e. So E is equal to R minus C, so we'll write it in that form, E is equal to R minus C. That implies d square c by dt square plus 8 dc by dt plus 64c is equal to 64r, bringing c to the left hand side. So now when we take Laplace transform on both sides, okay, of the above equation, that is this, then we get Laplace transform of d square c by dt square plus 8 dc by dt plus 64c is equal to this 64r. So this becomes S square CS, this becomes 8S CS. I know I have not discussed about Laplace transform in engineering mathematics or signal systems, but this is, if you have some basic idea, you are watching this video related to control systems, so I assume that you have some idea about transform methods, the basic properties of Laplace transform. So this is 64 CS and this is 64 RS. Okay, so here we'll take CS common, so this becomes S square plus 8S plus 64. This is here 64 RS. So now we'll bring it in CS by RS format. So CS by RS, which is the closed loop transfer function, that is equal to 64 by S square plus 8S plus 64. This is the format that we want. And in the previous questions that we discussed, the format was either given in this way or it was given in the open loop transfer function form. Then we converted into closed loop transfer function. So this is the basic format of a second order system, okay, which is in this way: k omega n square by S square plus 2 zeta omega n S plus omega n square, okay, CS by RS. So like I said, sometimes this k is equal to 1, which is in this case here, or in some other cases it is not equal to 1. So now we'll find out the various parameters which has been asked. So first, if we compare this denominator, which is the characteristic equation, with this, okay, then here omega n square is equal to 64. Omega n square is equal to 64. See this one, S square plus 8S plus 64. Here it is S square plus 2 zeta omega n S plus omega n square. That implies omega n is equal to 8 radian per second. The first parameter we have found out. Then comparing this 8 and 2 zeta omega n. 2 zeta omega n is equal to 8. That implies zeta is equal to 8 by 2 omega n, which is equal to 8 by 2 into 8, which we have calculated here. Omega n is equal to 8. So this gets cancelled. So zeta is equal to 1 by 2, which is equal to 0.5. So zeta is equal to 0.5. Okay, we have calculated that. Then it has been asked to find out the delay time. Okay, so delay time taken by the output response to reach 50% of the steady state value. Delay time TD is equal to 1 plus 0.7 zeta by omega n, which is equal to 1 plus 0.7 into 0.5 by omega n is equal to 8. So this we are getting 0.16875. okay, it is coming around 0.16875 seconds. That is the delay time. Okay, then we have the peak time. Okay, peak time is the time taken to reach the first peak value, the maximum value Tp, which is pi by omega d, which is equal to 3.14 by omega n into root over of 1 minus zeta square. That is equal to 3.14. Omega n we calculated here is equal to 8, zeta is 0.5. So it is 8 into root over of 1 minus 0.5 square. That is equal to, it is coming 0.4532 second. 0.4532 seconds. Then we have peak overshoot, which is given in terms of percentage. So percentage of peak overshoot is equal to e to the power minus pi zeta by root over of 1 minus zeta square into 100, which is equal to e to the power minus 3.14 into zeta value we calculated is 0.5 by root over of 1 minus 0.5 square into 100, which is equal to, it is coming around 0.1631 into 100, which is equal to 16.3%. okay, the percentage of overshoot, peak overshoot. Then we have to find out the settling time. Settling time, both values we have to calculate it for 2% error, for 5% error. So settling time Ts for 2% error is equal to 4 by zeta omega n, which is equal to 4 by 0.5 into 8, which is equal to 4 by 4. See, 0.5 into 8 is 4, 4 by 4, it is equal to 1 second. Then settling time for 5% error, because the output response, it generally settles in between 2 to 5% of the steady state value. So it is 3 by zeta omega n, that is equal to 3 by 0.5 into 8, which is equal to 3 by 4. So that is 0.75 second. So these are the two settling time values. Okay, so here we calculated the parameters which were asked for this system, which was represented by this differential equation. So the first task was to convert this differential equation in time domain into S domain using Laplace transform method, which we got this result. Then we found out the important parameters such as omega n, undamped natural frequency, and damping ratio, and then we determined these parameters. Okay, so simple, just remember the formula, put the values and get the answer. Okay, so these are some of the questions related to we discussed simple questions, so we'll discuss some more higher order conceptual questions in the upcoming videos. So I hope you like this video, a set of videos, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.